may facilitate the dysfunctionogenic fungi, and then mycotoxin occurs in different parts of the crops. How we can combat, how we can minimize mycotoxin? We can, as you know, mycotoxin is up and along the chain. We can do the prevention in the pre-harvest in field, but also in post-harvest reduction. We have some method. So this is some different measures that we can use as a good agricultural practice, including resistance, fungicides, agronomic and biological control, and predictive models in the field. If we move on the post-harvest, we have physical, chemical, biological, as a sorting, absorption, use of acid, hydrogenation, microorganism, and enzyme. So for this complexity, we have some possible solution, not to eliminate. This is absolutely not possible, but just to minimize. That is our key words, minimize mycotoxin effect during the long chain. So, but of course the pre-harvest is quite complex, is a limit control problem and the side effect of corrective action. If we move on post-harvest, it's more simple. Good agricultural practice, limit toxin accumulation and no side effects. So it is more easy to handle as a post-harvest than pre-harvest. But moving on toxin production, as you know, this is the main toxin regulated toxin. And then you can see this is a wonderful picture that you show you the different toxic effect of mycotoxin. And then all these main toxins have an immunotoxic effect that is really strong and common toxicity for all these metabolites. And this means that they work perfectly as a synergistic activity, reducing the immunity. And then, of course, all animal, human, are more exposed to different toxins, to different other disease. Just as an example about, you well know about human impact of toxin with some really severe disease, also in India. And then the different chronic attack, particularly the liver cancer. So this is a toxin. Think about this is the most cancerogenic natural compounds in the world. The most cancerogenic natural compounds of toxin is unbelievable. And this is also an effect of animals, so chicken. But there is a chronic effect and the pathogenic effect, but it's chronic. Also in order to reduce the production of chicken. This is just different toxicity towards different animals. Anyway, going towards the regulation. So this is, every year this is improving of attention about the regulation worldwide. And then this is show you the different mycotoxin regulation in different countries related to the food and the feed. As you can see, if we look at the food, we have Europe as more regulated contents, followed by North America, Asia, and Latin America, and last is Africa. Moving on the field, we have North America that is keep more attention, followed by Europe. So there is two different regulations. That is not understandable because, of course, particularly for the human, we have the same, the toxin can be have the same effect towards human in Asia, in Europe, in Africa. So it's not well understandable, this kind of different regulation. But anyway, this is what is happening. About, for example, a comparison between Europe and Africa, you can see there are different regulation, different force of regulation. So EU, for example, regulation for 12 mycotoxin. Africa country have just 15 African countries have regulation. That means almost 60% of regulation. Most countries not regulated, but say that regulation needed. And problem does not exist. And for small scale substance system regulation has failed. So this is very big differences in terms of regulation. And as our friends from India, he emphasizes, underline the difference and the cost of toxic contamination in Africa. And this is a huge in terms of losses And also, the important things that they underline, but I will also talk about later, is the best quality is exported and the poor quality consumed domestically. That is not the acceptable. That is part of the ethical issues that we have to take into account. So this is, of course, the problem. Mycotoxin is also a big effect in terms of trade. And then you can see it is just how many crops can be can have this problem in mycotoxin trade, in trade exchange in the rest of the world towards Europe. And then this is a long list: maize, cereals, coffee, pistachio nuts, peanuts, soda nuts, spice, and you well know what's up. So this is just I'd like to emphasize how mycotoxin have a really impact in terms of reproductive health system for food and feed in Europe. And then, just some years ago, we under the umbrella of a big project, of MycoG project, we launched of mycotoxin charter. So this is just a paper on mycotoxin that emphasizes the importance of awareness about mycotoxin and how we can minimize mycotoxin exposure worldwide. That is just an important point that we have to underline. So we consider unacceptable that practices to reduce mycotoxic contamination exist, and the resources and the efforts are available to implement these practices can be insufficient, and multiple points along the food chain. Second point, we cannot consider unacceptable. We can consider acceptable that the inspection, regulatory, and enforcement capability often are inadequate, especially in developing countries, and when applied are not applied uniformly. This is not acceptable for this ethical point of view. And then there are also justifiable inequality in the opportunity for people to access food that contains level of mycotoxin below the considered safe for human consumption. People suffering from chronic hunger, malnutrition, and have started to grow are also exposed to higher level of mycotoxin. And used for human consumption are wasted due to the high level of mycotoxin contamination. This is really important. So, and this with our idea is that our suggestion that in the near future mycotoxin problem is expected to have still more importance due to the variable factors as consequence of the climate change, fungicide resistance, the spread of toxicity in the population at the global level. And output most of all of countries have mycotoxin regulation for at least aflatoxin. There is still lack of a specific mycotoxin regulation or a poor regulatory and control system, especially in the developing countries, which are usually the most exposed to mycotoxin release. Greater dietary diversification and less dependency on specific crops is crucial to reduce the level of mycotoxin exposure. This is, thank you for your attention.
Thank you. Any questions or query arising out of this presentation? You are open to answer? Any questions from the audience? Anyone? Okay, so your question was?
It's very nice that we would see a great recognition of mycotoxin. And most of the reports say that people take this contaminated food and leads to cancer. This report across available. Now coming to India, what is the status? We have any policy on mycotoxin monitoring, testing, regulation, enforcement. Is it in the purview of SDRs?
Actually, this is not in the purview of insecticide Act. This is the purview of FSS Act 2006. The Ministry of Health and Ministry of Health they are dealing, but it's included in the FSS Act 2006.
The important topic, every time we say that poor people take mycotoxin, rich people take pure, that is a very big issue.
So it is only perception that these people are taking good food. We don't know what is being processed. So during last year, I think TNAU submitted a project to Animal Husbandry Department for how we are going to sample out the maize which is going for the feed. So TNA was submitted a project and we approved that, and also expanded its purview that you go also have a sampling procedure so that FSSAI can adopt that sampling procedure for I think someone must be working on that. And for DDGS also, that is after producing ethanol from this maize, what is the level of this aflatoxins in the DDGS which is going to the feeding. Even though FSSAI and others have made a norm that not more than 20% of DDGS should be added in the feed, but still, if there is any scope to check the mycotoxins or the aflatoxins in such kind of material. But we at the level of Government of India, we are promoting good agriculture practices for maize cultivation so that minimum aflatoxins can be produced. So that kind of agronomy with good agriculture practices, we are promoting it on large, and we have a WhatsApp group also for the maize production to reduce aflatoxins and fall armyworm problem in this one. So anywhere if some report is coming, we are trying to analyze that and trying to give the advisory materials for it. So that is the development. So just for translation for the farmers.
விவசாயிகளுக்கு அனைவருக்கும் வணக்கம். நம்முடைய தற்பொழுது பேசிய முனைவர் அண்டோனியோ அவர்கள் இத்தாலி மாகாணத்தின் ஆராய்ச்சி கழகத்தினுடைய இயக்குநராக உள்ளார். அவர் இந்த பூஞ்சானத்தினால் உண்டாகக்கூடிய உணவுப் பொருட்களில் உண்டாகக்கூடிய நச்சு பொருட்கள் சம்பந்தமாக பேசினார். எந்தெந்த நாடுகளில் எல்லாம் உள்ளன, எவ்வாறு பரவுகின்றன, ஒவ்வொரு நாட்டிலும் என்னென்ன அதுக்கு உண்டான கட்டுப்படுத்தும் முறைகள் மற்றும் அதுக்குண்டான சட்டத்திட்டங்கள் உள்ளன என்பதை பற்றி மிக விளக்கமாக எடுத்துக் கூறியுள்ளார். இதை பேஸ் பண்ணி எப்படி எப்படிலாம் ஐடென்டிஃபை பண்ணலாம், கண்டுபிடிக்கலாம் அப்படிங்கிறத பற்றி விளக்கமாக சொல்வதோடு மட்டும் இல்லாமல் இந்த மாறுபட்ட சீதோஷ்ண நிலைமை முக்கியமான காரணம் இந்த பூஞ்சான நச்சுக்கள் வரதுக்கு அப்படிங்கிறத சொல்வதோடு மட்டும் இல்லாமல் மேலே அதை எப்படி கட்டுப்படுத்துவது, ஆர்வஸ்க்கு முன்பு எப்படி, அறுவடைக்கு பின்பு எப்படி என்று கட்டுப்படுத்துவது பற்றியும் விளக்கமாக எடுத்து கூறினார்கள். நம்ம மக்காச்சோளத்தில் எவ்வாறு உள்ளது, அதற்கு தமிழ்நாடு வேளாண்மை பல்கலைக்கழகம் கொடுத்த திட்டங்களை பற்றி விளக்கமாக எடுத்து கூறியது மட்டுமல்லாமல் அதற்கு நம்ம அறுவடைக்கு முன்பு மற்றும் அறுவடைக்கு பின்பு கடைபிடிக்க வேண்டிய நம்மளுடைய தொழில்நுட்பங்களை கடைபிடித்தாலே, நல்ல தொழில்நுட்பங்களை கடைபிடித்தாலே கட்டுப்படுத்தலாம் என்று எடுத்துக்கிட்டார். நன்றி.
For that very elaborate presentation. Now we move on to Dr. Lorena Aaron Maxwell. She is scientist of plant pathology, WVC, Taiwan. So, Dr. Lorena, please.
Thank you. I am originally from Mozambique. This is in the southern part of Africa, and my official language is Portuguese. So I hope I will talk slowly so you can understand my accent. And one funny thing or linkage with India is that the Portuguese find my country looking for India. So they were looking for India and they land in Mozambique. So I work at the World Vegetable Center, and I want to say we are very, very grateful for the collaboration we have with TNAU, mainly with the crop protection team, plant pathology and entomology. We always receive students, visiting scientists, and we are open. So one of the first policies I want to share is that World Vegetable Center is an open science center, and we welcome always students and visiting scientists, and we are honored to have TNAU scientists and students in our campus every year. Since I joined, we always have someone from TNAU in Taiwan. So thank you for all the support and collaboration. So our conference focused more on the One Health approach. So besides plant health, plant protection, the One Health approach recognizes the human health, animal health and the environment that are interconnected. And control and policies is one of the bottlenecks for successful use of biological control with farmers. And in my view, biological control aligns very well with One Health approach, because besides of protecting the plant by reducing the application of pesticides that we know it can harm humans, the person applying, it can reduce the residues for the feeds or animals that consume also the plants, but also we know that reduce contamination and pollution in the environment and enhances biodiversity. So biological control touches every framework of the One Health approach. But, however, regulatory pathway of biological control are often more strange and time-consuming. Now, I know those people who work on chemical pesticides, we know that chemical pesticides also has a long process, but it's more clear. There is a process in place, and sometimes it's very similar across countries, it's very global known. It can take time, of course they have to prove they are safe as well. But with biological control, it's still much more complex, much more, very different from country to country, what complicates even more commercialization. I know India actually, I want to congratulate India. India is one of the countries that is, compared to many other countries, is advancing in policies for biological control. We still have to work, but it's still out there. There is a lot of biological and companies as well, many companies working on producing biologicals. But if India wants to sell to Nepal, for example, a chemical pesticide is going to be easier to register compared to a biological. So it means that there are few disparities that we have to work on. Another problem, mainly for plant protection, when we talk about biological control for pest and disease control, for example, compared to biofertilizer for soil fertilization, you can see that you can have the same microorganism, say a bacillus, that also has capabilities to enhance soil nutrients and also control the soil-borne disease. It's easy to register that microorganism has a biofertilizer. The process might be easier compared to register if it's to control the disease. Why? Maybe the experts can reply, because I know you mentioned that in the government you have different sectors and one of them is safety. If the major problem is about safety, it's the same microorganism, but it will be easier if we say it's biofertilizer. So these are a few of the things that we need to discuss and continue to work on policy on biological control. So I want to leave three recommendations on my view, working on biological control, and both actually work in different countries. In India, for example, we are much happier that there are few products available, but for example, if we go to Indonesia or other places, they don't have any, and they don't have many policies in place. So we have these differences in progress. So one of the first recommendations is that we need a harmonized, science-based regulation. Different chemicals, different mode of action, different type of microbes, synergies. They need to have an harmonization how we will actually regulate biological controls. Also within countries, for example, within regions, if we can work together, because we not just want to consume, use on our countries, but maybe commercialize. The companies want to commercialize. So if within our region, let's say our neighbors here in India, Nepal, Bangladesh, if we can sit together as a government and discuss how can we harmonize regulations for biological control, maybe it will be easy to advance this agenda of having a clear, more easy and less stringent registration of biological control, because for biological controls, the bottleneck is registration. We can do good field trials, we can identify good microbes, but then when it comes to registration, the companies always have to spend a lot of money, longer time to have that process registered. Another thing I have here that is important is collaboration across different sectors. One is to promote and to produce biocontrol, and that will help in the policy. I was actually very happy from the previous section when the private sector was mentioned that they have MOU with TNAU for field trials and testing the biocontrol. That's helped a lot, because if more companies can collaborate with research centers for data, for creating good science base, it will be easy also for the policymakers to see the data, to streamline more biological controls. There is something often that is very interesting. For example, we have a disease. You can find several chemical products for one disease or pest. Several for whitefly, you can have different or two chemical pesticides, but biological control, sometimes you just find one, only that one, and people are happy. No, we need different as well. We need to rotate, so it's very important that for One Health approach, not only TNAU, crop protection should collaborate with these private sectors, but also the environmental department will join on the experiment. So we already gather more data for environmental, the medical department as well for human data. So you gather already the data, and this may be easy for policymakers to find a process, a more streamlined and fast way to promote more registration of biological control. And my last strategy is, of course, is educate and incentivize stakeholders to adopt biological control, mainly the farmers. I feel like the farmers still have some hesitation, because of course it's their crop, they want to protect their crop, they don't want to gamble with their crop, but there is that hesitation, biological control is slow, it's not more effective. So if they don't claim for the importance of biological control, also it's not going to be in importance of the policymaker, because the farmer is not giving the importance. So we need to create more awareness, we need to incentivize more use of biological control. One example that comes in mind, I did my PhD in the US. In the US, when you go to a supermarket and it has a logo of organic, automatically people think it's healthy, is environmentally friendly, you are doing good to the world and society of eating organic. But for biological control, people don't associate with that. But we know that it has the same value. If a farmer uses biological control to protect their plant, is producing healthier, safe food, is thinking about the biodiversity environment. So we need to also put the biological control as this premium, I would say product, but also way of living. So I think if we give the importance of biological control and the play roles on One Health approach, it will also help push the policymakers, it will also help push people to adopt and use biological control. So I think these are the few strategies I thought that may help in advanced policies that can help biological control to gain importance in the context of One Health.
Amina. Yes, you have talked about a very complex system, biological control, because we cannot see biological control agent from just one perspective of biological control agent. On what environment they are to be applied, what are the varieties being cultivated there. Say some insect tolerant variety comes. So your whole system has a change now. Now that you have, then the biological control agent cannot survive on that variety. That pest which would have affected that variety. So this whole chain, it is very difficult to manage, and that is the main reason why biological controls are not getting that kind of importance in the system. Because once a farmer is in the field, say his crop of brinjal is going to be affected by some borer, so he will not wait for the biological control agents to come and then save his crop. He just go for some chemical or some other system. But if that insect is coming regularly in a particular area, in a particular environment, then yes, government can have some strategy that this kind of biological control agents can be released in that area for a long period, so that they can have a natural presence in the environment, and then whenever that insect or something is coming, they can control it, automatically control. But if you think that once, because most of the treatment in India, whether it is human or crop or anyone, we are going in for symptom-based treatment. So once a symptom is there, so you have very limited time to control the insects through biocontrol. That is the issue. TNAU has say 10 very good biocontrol agents. So they should, the companies, private companies, they should come and then pay for the license fees or something. That kind of structure is required. Everybody cannot work in the field to develop such kind of thing. So a strategy should be like we should identify the important environment, important insects on which biocontrol agents are to be used. Say nematodes, very good systems can be developed because it is present everywhere. Nematodes are present on a very large scale. If some biocontrol agent comes for nematode, yes, it will be accepted by all and it will survive in the field throughout the year. You don't have to release it season after season or behind the crop every time. So such kind of systems, it comes, you said something about the time, duration of the cost involved in registration and regulation. Nothing. It is peanuts as compared to the research cost. We don't take time. For biocontrol agents, we are giving what we call it as 93D, that is provisional registration immediately, not even taking more than 3 to 4 months. So the moment these applications come, we are going for provisional registration. So that is not a big issue. The big issue is how much we can produce, how much we can release in the environment, and how it is going to establish in the environment for sustainable presence in the environment. That is more important. So thank you. Anyone else can ask any question. So if not, then for some translation. So someone wanted to ask? Yes, please. You can come in the front so that we can hear you.
We use biocontrol agent because it is known to control several insect and pests. But after several studies, after a long period of study, when it comes to a position that some of the biocontrol agents comes out as pathogenics, so even to humans. So how do you think you have to deal with such problems?
That's my personal opinion. It's not very scientific, but it's just my thinking. For example, I will give a case of aflatoxin. I work a lot in developing biocontrol for aflatoxin, and one of the strategy of biological control of aflatoxin is number one, when we look for the biological control, we look for a microorganism already present in that area. Is there, okay? So we are not introducing something new, is there? So the same question is, if it was there, if I just add to reduce my population, all other question is there, it was there before. I'm not bringing any new thing in the system. Is there, if it was producing something, it was in the environment, that's my thinking. So the strategy to address this complex of questions is not that we are introducing maybe I didn't make clear on the different type of mode. I think one of the strategies reduce a lot the introduction, but manipulating the beneficial in that environment. And one of the things we do is the process is the same. We are in India, we look for a same genetically qualified atoxigenic microbe that is able to control, but is from this region. For example, we will have maybe an isolate from Tamil Nadu that can control aflatoxin from Tamil Nadu. And then very far from here, I don't know all the states of India, somewhere very far we might have another microorganism. So to answer your question, in terms of pathogenicity, what makes pathogenicity, in my opinion, is the damage and the quantity. So we need to control that. So we need to balance the environment. So when we bring the biocontrol is to balance the pathogen that it was there. Usually, we will have make the studies, the R&D, the test to ensure that that microorganism is not pathogenic to most of the crops or in the area to human, to other crops. And we will not choose this as our candidate to help. Now, if in the future it changes, it's because of mutation and maybe we cannot control that. I don't have a specific question for you, but if we do our homework of good R&D, make this value chain of different private sector, research sector, everybody who can help in this process, not just the company trying to do everything. Maybe we can reduce the level and the percentage of success. And we have a lot of success of biological control. Actually, we pay more attention to failures than the success. I think we have a lot of success, and I think it's a good system because now people are looking, chemicals also are dangerous. A lot of people die with cancer and many things, but it's not always focused on that, but for biocontrol, we focus on that. I think if we want to look at one health approach in the environment, of course, it's not a perfect system, but it can work. There is a system that can work. Thank you.
Especially the stakeholders and the researchers. We, the Ministry of Agriculture, frequently we used to organize an open house meeting with the Biopesticide Association and industries and stakeholders also. We used to get the comments and we are encouraging them to go for the registration of pesticide. As our chairman said, he clearly mentioned that. So in India, the registration of biopesticide, it's not that much big deal. So we are simplifying the guideline and the time frame for the registration of biopesticide is so very less compared to other states. So the simplified guideline, if the strain has already registered meaning, it is not required to go for the data generation from all the angle, even toxicity, bioefficacy, because already someone has generated, so the strain has registered. So if you are going to change a formulation or active ingredient or CFU count, then you need to generate. So this is a common thumb rule. So the main concern is safety and efficacy. So we, the government of India, we have simplified the guideline and registration process, and we are encouraging our farmers and regulatory people to go for the registration and use of the biopesticides. So these points I am supporting for your presentation.
Back to this campus after so many years, so thank you very much for the honor. I went on to do my master's at IRI and a PhD outside, and I spent my first 6 years in research in places like EASY, ECP, and University of Wisconsin-Madison. And then I moved into the industry where I did a number of roles from all the way from R&D to regulatory to eventually running businesses. I was the managing director of BSF and also another company our commissioner might know called PI Industries, which is out of Udaipur. Yeah, but then currently I'm back to academics. I'm the dean and director of a business school in Mumbai called K.J. Somaya Institute of Management. So I'm going to really talk about, my fairly long, I almost feel ancient because you had very kindly deputed one of your associate professors to receive me at the airport, and as I was speaking to him, I told him that I graduated from this college in 1979, and he gently reminded me that he was born in 1977. So, so I feel a little bit ancient. So one thing that comes with this anciency is that you have a lot of experiences that I can share with from this perspective. So let me start with this One Health, which is this inextricable, that's the right word, interrelation between the humans, animals, and plant and environment. See, in ancient civilizations like India, this is nothing new. We've been talking about this 100, 200 years ago, about how we need to look at these things in a very comprehensive way. So it's a little bit ironical that 200 years later we are here kind of revisiting that topic, and at least it's good that we are revisiting it. Now, why is this important in a country like India, with 1.5 billion people and about 550 million livestock, and the kind of biodiversity that we have in this country? I think this concept of One Health, which has stemmed from this zoonotic diseases and how it transmits from living organisms to humans, has very, very high importance. However, anything that we do with One Health also needs to be seen in the context of India's food and nutritional security, because at the end of the day, we are going to be 1.5 billion people in the next 20 to 30 years. As we become more, our per capita income increases, we are going to be consuming more and more protein from alternative, kind of sources, and hence the pressure on agriculture is going to be humongous. And so sometimes when we talk about One Health, there is a tendency to always think about organic farming, etc., as a solution to One Health. But what we need to remember is that that may not be a solution, but sustainable intensification of agriculture is finally the real solution to having a One Health kind of approach to meeting the nutritional and food security, and also making sure that we have a healthy life. Now, it has been proven that while sustainable intensification of agriculture increases production, it does even probably better than water use efficiency compared to organic agriculture. There are downsides to it. It affects biodiversity, it emits more greenhouse gases. But at the end of the day, a country like India, we need to, think about the trade-offs between these various options and choose the right option for the larger population. So that's the context in which, I think the role of industry has become extremely important. And I'm going to talk about how industry is contributing to this in three broad areas. One is really industry has contributed in the last 50, 100 years in terms of coming up with innovations for safer alternatives. As the regulations have gone up, as we start to recognize adverse effects of some of our solutions, I think the industry has stepped up and really brought in newer and newer solutions. Even in the conventional crop protection area, I think the number of new products that are coming in, and our representative from the regulatory agency talked about how India is really helping to speed up registration of newer and newer molecules. Many of these new molecules are very, very benign from an environmental, from a human perspective. So I think that's a big, push from the R&D side that many big companies have made, which is research in that. But even more important is the how industry is using technologies like the GMO technology and CRISPR technology to even produce planting materials which are much better, an inherent kind of disease and insect protection. Now, as a part of BSF, we have a seed company and we have an R&D center in Bangalore. In crops like tomatoes and brinjal, there is no more breeding for increasing the productivity of a crop. Most of the breeding is aimed at reducing, imparting viral resistance to these crops. So these are the technologies that is really helping to bring in newer technologies. I want to particularly talk about one topic, that Maxwell brought out, which is how biocontrol and biological organisms are increasingly playing a role. And here I want to talk about a small experience. I'm associated with a company called Godavari Biorefineries, which is a sugar company which makes ethanol and has a captive sugarcane farming area of about 100,000 hectares in the state of Karnataka. And here we really are now, gaining a lot in improving soil health by isolating inoculant microorganisms in and around the catchment area, and able to then cultivate it and then give it back, just as you said, to enhance the level of microbial. At the end of the day, I think the number of people that are meeting farmers from an industry side is much more than many state agricultural extension services. Indian startups are playing a huge role in enabling, sustainable agriculture to be practiced. And let me give you two examples. A company called Krishi Tatra, which uses IoT-enabled devices to really understand soil moisture at a very, very precise level and make recommendations to farmer on, really effective use of application of irrigation. So that's one example. The second example that I wanted to also highlight is again a company out of Bangalore called Satshore, which has been in existence for almost 15 years, which have really, gone to the cutting edge of using satellite images across the world to predict yields of crops. Today they are working for companies like Olam, so that Olam can have future, pricing of cashew nuts in Ghana. That's the level to which digitization and data is currently being used, and Indian startup companies are, using this. And at any point in time today, there are probably upwards of 250 startups in the area of agricultural innovation, which is coming up with a number of innovative areas, not just on the supply chain front, but also on helping farmers to make the right decisions in terms of crop protection. So that we, industry, academia, regulators, policy makers, and I was just sitting here and thinking the way we are sitting here today, where the regulators and scientists are on one side, industry on the other side, the farmer on one side, and the policy makers in the middle, is a telling example of why we still don't have enough communication and respect for each other. And I think in the interest of food security of India and nutritional security, I think it's very important we change the structure of sitting and talk to each other much more. Thank you.
Dr. Raman, very good point raised by you, and I think many issues on which we are working, it may not concern the farmer directly, but yes, it is more directed towards us. So we will try to finish it out. You may tell the farmers what it is.
First of all, thank you the TNA administration and especially CPS director for giving us the opportunity to share our perspective here. So I would like to share the designing and developing of sustainable crop protection solutions. So how the industry is helping us to bring the product safer, and I will connect upon with what are the regulatory challenges which we have. So to introduce myself, I am Edwin Rockbell, based at Hyderabad, leading the R&D function for crop protection division of whatever Agri-Science. I am alumni of JNU from Madurai campus. I started my career here in Coimbatore as a field scientist. Before that I was a sales trainee. Field scientist covering Tamil Nadu, Kerala, and then I moved to handle fungicide, herbicides in the South Asia and also in the APAC region. And when Corteva is formed by the merger of Dow, DuPont and Pioneer, I am spin off into 3 different companies. One is Corteva Agri-Science. When Corteva was formed, I moved to the global biology role based at Singapore. Then I moved back to India to lead the marketing function, one of the category. Then I moved back to R&D. I gone through multi-diversity roles in my career. So since students are here, that will be an example for them, so to show the opportunity in the industry also. So how Corteva snapshot, we are operating in 110 countries, in the market cap of $40 million. Last year our revenue reported was $17 billion. We have 22,000 plus employees, and around 10 million farmers we are serving. So our seed, number one in corn and soybean, that's a pioneer. And largest biologicals, I'll touch upon how we claim that one. And we have 400 seed and CP solutions. And the current technology is critical to solving some of the world's biggest challenges. We already discussed that, the food security, and then climate change, which is impacting the yield and other pests and diseases, and energy transition. We discussed during the break about how the some of the food grains are going for the energy production and all. So that's also a challenge, and farmers are facing a lot of challenge to match up the producing the yield, because land availability is going down and down, and they are facing a lot of pest and pressure, pest and diseases, and stringent regulations. So for a seed, on an average, is 16 years, and for crop protection, as Dr. Raman mentioned, with the $300 million, that is 2,500 crores in Indian rupees with 12 years. So that's how it's taking more time. And sustainability area of focus, and we have heard in the morning session also, Syngenta, UPL, Indophil, rallies, everyone touched upon, and all the point what I would like to bring here is most of the R&D companies, from their discovery, they inbuilt the sustainability goal to protect the biodiversity and to control greenhouse gas emissions. Like we are promoting, especially in the rice area, from transplanted rice to direct seeded rice with some solutions, and inclusion and diversity. So how do we do it? We focus on the farmers first, and it's a big puzzle. Crop protection innovation or discovery is a big puzzle involving the regulatory challenges and sustainability criteria and durability. If you bring the product, it should sustain for a long time, because a lot of challenges on the resistant development and controlling the emerging pests and diseases also, reduced use rate, mode of action, drift. Nowadays new technologies are coming, drones and all. It should meet that also. So hence sustainable innovation is important, and Corteva we committed to bring products which are meeting the sustainability criteria. From meeting the land and environment, so that it is safe for the environment and not leaving any footprint on the soil or atmosphere, and communities, because the shorter pH. Some of the product, if we spray, we cannot consume it for a minimum particular number of days. We need a shorter pH, and at the same time broad spectrum control, and for the farmers also, how to handle. If they are handling, it should be safe. All these things are inbuilt, and FAA brought sustainability goals, 17 goals. In that, Corteva selected 5 goals, like zero hunger and clean water and sanitation, then climate action and life on land, and also responsible consumptions. So these we inbuilt, how do we bring a product, a novel mode of action, and also reduce risk to the groundwater, and use rate, less use rate. So compared with the conventional product, and if you see all the new product launched from the new chemistries, they are all very less usage. So the different stages, we screen, create a full guideline so that we can generate data. Like you mentioned, it should be safe for the local organisms and local environment. So, but if we have some guidelines, what are the data needs to be generated, that we can take and bring it faster. These are all some of the examples I brought here, and that was my last slide. Thank you for the opportunity.
Should be short, huh?
I'm trying my best. And we do a lot of regenerative agriculture for sustainable and bioavailable active natural ingredients. We produce plant-based vitamins and minerals. So this is a brief introduction about me. And now getting into One Health regenerative context. See, Linus Pauling, a Nobel Prize winner for vitamins, has once said that the continuum of malnutrition is associated with all the chronic diseases we get today. And not just the continuum of malnutrition associated with just human, animals as well as plants. There is a connect. So I want to pick a small example from my industry. Vitamin B12 is an important global problem today because it is closely associated with the degenerative neural health and the vitamin B12 deficiency is a global problem. And the world seriously believes that unless you take animal food, vegan don't have the vitamin B12 source. I just want to take you through a small example. Let's take mare's milk, horse milk, cow milk, and then mother's milk, human milk, and the cholesterol. Over the last 50 plus years, there's a research that says that mother's milk has gone down in its B12 levels 1,000 times. And then it is at a level of 0.01 or something. Mare's milk is continuing to keep its, to some extent, is continuing to keep up its B12 production. And then the horse is a herbivore. It does not eat animal food. But today we are believing in vitamin supplementation. We want to eat animal food. I mean, people, the vegan people are worried about the B12 nutrition just because there's a whole lot of degenerative thing that has happened in the system that has led to a point where genetically we are degraded, that we are no longer the same. For years, 50 plus years, we are no longer the same. If you look at the, connecting this to the plant, if you look at the topsoil erosion, plant genetic erosion, microbiome erosion, leading to nutrition degradation in the food supply system, poor dietary health. So we are very closely connected. In the spectrum of One Health, you've seen that the environmental health, animal health, plant health. Probably you can put the plant health in the center and then try to associate environmental health, animal health, and human health. It will make more sense because plant health plays a major role in influencing the environmental health, human health, and animal health. So today we are fortifying, but fortifying is a temporary solution. Regenesis is the only solution. Can we go back to our original potential should be the idea of research. Because my perspective is going to be a science perspective and then connecting the policy towards it, not a fully policy perspective. The next. What is regenesis in plant health perspective? I think it's very important, more from the scientific perspective to understand. Plant protection, probably I want, for convenience, I want to use the word crop protection and plant protection together. Crop protection, for instance, it's a kind of a post-mortem thing where on the standing crop, what if something happens, what can we do with it? But plant protection, I think we should look at more from a holistic perspective, more from the research perspective. We know that we seek insecticides, pesticides, or some kind of disease, not exactly defense, disease curating systems. But I think the plant protection should more focus on plant defense. It's more like, you can compare in food safety systems, we talk food safety separately, food defense separately. Similarly, crop protection separately, plant protection separately, and then we should start focusing more on plant protection from the defense perspective. I think that will make more sense because crop protection is like you can't help a disease occurred, you have to do something. A pest incurred, you have to do something. So the entire regulation will probably focus on aligning that and streamlining that. It is the research ecosystem that should probably focus more on. One of the examples I've taken is here, garlic. 50 years back garlic, 30 years back garlic, and garlic now. What has happened to it? Like, garlic was famous for its pungency. It is directly connected to cardiovascular health. Today's garlic is connected to dietary fiber health. You look at the competition, I've taken some accessions, our company, because while selecting the right ecotype for our own nutrition, we have done the research on 625 plus accessions that the onion and garlic research ICR has done. We try to pick up the high pungency varieties. I can even quote the Ooty variety. It lost its pungency when it was, what was its pungency once and what is it now? The expression study is there is a competition during the bulb formation stage between the alliinase genes versus the fructan genes. And then the fructan genes succeed. It's a problem, it's a kind of, you was talking about the stewardship. One molecule stewardship, similarly varietal stewardship, genetic stewardship. Are the varieties remaining the same since we launched and now? How potent are they when it was launched and what is its potency right now? Are they really solving the problems for which it was originally designated? These questions have to be asked. I think probably plant health, plant protection has more perspective towards genetic health of the plant in terms of its varietal, pure lines or hybrids or whatever it is being selected for, because the system, ecosystem continuously puts pressure on anything.
Are returning back to our traditional roots, and that kind of requirements are there now. So let us move to Thiru OVR Somasundaram sir, but be brief sir.
Humor as a father and grandfather. Why? I am worried about the elder generation. Right? Why? India is the number one. Is a capital of cancer. 70% of the death 3 years and by cancer. Why? Toxic food what we are consuming. Everything, including curry leaf, everything. But you must all understand what you are indiscriminate use of pesticides. The department should have the power to work with along FSSA. Otherwise, very difficult. Then US egg is not getting in high demand. Why? Bird food. So birds and animals and plants are playing a major role in our life for food. So we must be very careful, And organic farming, but is it sustainable? Organic farming. The farmer could get a reasonable price for this product. That is not there. Even other products, nobody is calculating the cost of production for each crop. That you must encourage the top departments to work out the cost of production of all crops. Otherwise, farming community will go away from farming. They are not getting reasonable price. Anything, cost of production plus a margin, they are fixing. Who is fixing the price for agriculture, sir? Please tell me, sir. Sorry, sir. Then, good agriculture practice will be encouraged. The judicious use of chemical. Don't mistake me, sir. And sir, soil carbon level is going very low. That is the major problem. You heard about biochar, sir? Biochar. That is a stable carbon. You must make our department, universities, to work on more biochar. That is more important. Sir, Cornell University, they are doing a lot of work. Previously, our PNU was a dual program with Cornell University. That time I brought all the books, I gave it to university. No use. Now everybody is talking about biochar, conference everywhere. That is the only solution. You are helping in two ways. One, you are reducing methane production and helping the soil carbon, sir. Another thing, sir, I am skipping a lot. Paddy should come under drip to avoid methane and save water and more production. And under SRI. Sir, adulteration in a very big way, sir, everywhere. What are they taking the drinks, soft drink, everything? And the chlorify was, you heard about Rabak Ukuma? That is mainly with chlorify sir. Sorry, sir. Of the doctors telling, most of the people kidney and liver problem with magic medicine. You are responsible, sir. You are like a God, you have to tell. And sir, and sulfur fumigation for copra. They are going, people are going, they will give money and they will, without anything they will come out. Of course, FSSI it should be very strict. It should work along with our department. But say small farmers and marginal farmers are going away from farming. Why? Money attraction is not there. They are not getting reasonable price. All are going. Manpower is not available. If available, expensive with less efficiency. Then what is the solution? And you already fragmented that by land reforms and by nature, 1 son, 2 son, 2 son. Large scale mechanization is possible, not possible. You have to arrange small scale mechanization. You have to work more. Strengthen the systems to make development of resistant variety to pests and diseases and tolerant variation, drought and climate sciences. Science should be allowed on long-term work in research pests research project rather than being frequently transferred. A scientist who is working in coconut for 25 years, transferred to Gingerly, the knowledge is not going to help the crop farmers and the country and the consumer. Sir, you must be strict on this, sir. See, and our university, 500 scientists posts are vacant. How you can expect a good research? Sir, please tell me, sir. How can it possible? Here is the solution, sir. And polyose controlled condition is the only solution for vegetable cultivation, sir. Polyoses. But not in 1 acre, 2 acre. Sir, you must make a trust of like-minded people. 30 acres, 40 acres. Some places, some countries, they are using robot. Plugging, sorting and segregation and tagging. That's the thing, sir. We can expect, see, coconut, you know, heard about root wilt? From 1800 it is in Darwin and 82 it was in Kottayam and it had spread everywhere. So far, after working 130 years, they found out the phytoplankton is the cost. No reason, only cut and burn. Our university brought out a microbial consortium Cococan that is helping there is more, but there is a problem. The stirring, making, aerating is more obvious and more important. That is most of them failing.
Thank you. You have raised very important issues, and I can tell some of many places government is working on all these things. Say in Keshwar, and several other schemes, whatever problems you have told, yes, very genuine problems, and yes, from time to time government takes action on these things. And then value chain infrastructure, agri infrastructure, the fund 1 lakh crore interest subvention scheme. So such kind of funds are being there, but like you told about biochar, yes, that is very good, but the costs involved and the production capacity, how it is to be produced and where it has to be produced, and then why not direct paddy straw can be used for making biochar. So these things are there. So issues. So no, it's okay. I know. I know. Thank you. Okay. So yeah, she will add all those things. So you have to say, or it is time if you want to say something.
We had an important session and there was a very good gathering also. Whatsoever can we earlier here were a few policies, many times it is not implemented and there are a lot of issues involved. Now this conference they made a lot of information. I am sure that this will go a long way in refining our policy support by the government. They do policy, but the recommendation should come from the industries and other people. Thanks to them for making this. And in fact, I think that there are biocontrol agents they should make some novel way of doing this so that whatever registration procedure that fast. And second thing, quarantine is very, very important. Many places the nurseries are not at all authorized. And there should be a stringent monitoring system so that the transfer, especially the nematode from one place to another, that will make it very big. And third important thing, sir, when I NIPH, I saw these, some of the biocontrol agents, they are unique to the particular problem. And in the endemic areas, now the government should take some policy by giving subsidy for putting some of the biocontrol agents. So for example, groundnut, you have a root crop. Many times the people withdraw the crop. But the opportunity. Thank you, Doctor.
So thank you, Coach.
Thank you for everyone joining us and giving valid points. Surely every points will be taken into proceedings, it will be taken forward. Thanks a lot.